Welcome to Easy BTech, your guide for BTech and beyond. Today we'll learn about reflection and refraction coefficient of a transmission line when terminated through a cable. The transmission line, assume that it is a transmission line. The line is connected to a cable. Okay. If the surge is induced in the overhead transmission system, I am representing it is ZL is surge impedance of line. ZC is surge impedance of cable. Okay, keep in mind. Now here we will discuss the line connected to a cable. Here, if the surge is, this is the surge is induced in overhead transmission system, it is traveling through the junction of both, this is the junction, both overhead transmission system and underground cable is connected. How much waveform is transmitted to the cable? How much waveform is reflected back in this situation? Okay, now we will see the coefficients first. Already we know the resistance, the line terminated through the resistance. Here, if line is terminated through the resistance, I am writing formulas here. The line is terminated through the cable, I am writing the same expressions. Here we know that the transmitted voltage in terms of coefficient of transmitted voltage in a resistor is 2R divided by Z0 plus R. Here transmitted voltage V equals to R is replaced with ZC and Z0 is replaced with ZL. Okay, keep in mind. Therefore, it becomes for cable 2 into ZC divided by ZL plus ZC. Okay, this is transmitted voltage. Transmitted current equals to 2 Z0 divided by Z0 plus R for a resistance case. For underground cable, it is current. In underground cable, the current I equals to 2 into ZL divided by ZL plus ZC. Reflected voltage waveform V double dash in resistor is R minus Z0 by R plus Z0. In cable, it is ZC minus ZL divided by ZC plus ZL. Reflected current I double dash is minus R minus Z0 by R plus Z0. Here it is I double dash equals to minus ZC minus ZL divided by ZC plus ZL. Those are the reflected and transmitted coefficients under cable. It is under resistor. Okay, that's the difference. The formulas are same for both the cases. Those are the reflected, refracted coefficient of a transmission line terminated through a cable. Okay, now we will see a problem on this case. An overhead line, with inductance per kilometer and capacitance per kilometer is 1.3 millihenry and 0.09 microfarad. Connected to a cable having inductance is 0.2 millihenry per kilometer and capacitance is 0.3 microfarad per kilometer respectively. Calculate transmitted voltage, transmitted current due to surge of 100 kV, due to surge of 100 kV traveling to the junction, Here I am taking two cases. Case one is along the line towards the cable, along the line towards the cable means here this is the transmission line, connected to a cable. The surge is initiated here. It is traveling along the line towards the cable. This is the cable. Then how much is transmitted, how much is reflected? This is case 1. Case 2, along the cable towards the line, along the cable towards the line means the surge is, this is cable, this is a transmission line. The surge is initiated on the cable and flowing towards the line. This is the junction. Then how much transmitted through the line, how much reflected back to the cable. Okay, this is the problem they given. First we have to calculate the surge impedance of the line. The surge impedance of the line is L by C, transmission line inductance and capacitance. The transmission line inductance is 1.3 into 10 power minus 3 millihenry divided by 0.09 into 10 power minus 6 microfarad. Get it is 120.18 ohm. And ZC is also same formula, but we have to substitute the inductance and capacitance of the cable. The inductance and capacitance of the cables are 0.2 millihenry divided by the capacitance 0.3 into 10 power minus 6. Observe here the capacitance of overhead transmission system is less, capacitance of underground cable is more, then the ZC value is less compared to overhead transmission line surge impedance. Okay, keep in mind these two values. 120.18 is ZL, 25.82 is ZC. Now here I have to calculate the transmitted and reflected. First case I am taking the case 1. Case 1 is the surge is initiated in the line and towards the cable. Okay, already we derived the formulas for this case. Just use the formulas. Just try writing. The voltage waveform V equals to, this is the transmitted voltage. Transmitted voltage V equals to 2 into ZC by ZL plus ZC into V dash. Here 2 into 25.82 divided by 25.82 plus 120.18. Here surge voltage they given, it is 100 kV. Okay, directly substituting 100 kV it is in. Therefore the transmitted voltage you get is 35.37 kV. This is the transmitted voltage. Transmitted voltage is 35.37 kV. Now I calculate the reflected voltage wave. It is reflected voltage wave. This V double dash. This is V. Therefore, the reflected voltage formula is ZC minus ZL divided by ZC plus ZL into V dash. It is 25.82 minus 120.18 divided by 25.82 plus 120.18, 100 kV. You get it is minus 64.63 kV. Okay, means the line connected to a cable, if 100 kV is such, it is traveling through the cable. For this case, 35.37 kV is transmitted through the cable, and the remaining waveform is reflected back is minus 64.63. It is 100 kV. Okay, this is the values you get for this case. Like that, we have to calculate current also, current waveforms. Therefore, current I equals to 2 into ZC divided by ZC plus ZL into I dash. 2 into ZC value 25.82 divided by 25.82 plus 120.18 into I dash, you can write it as V dash by Z. Okay, it is 100 divided by 120.18. You get current value is 1.37 kilo amperes. I double dash formula is minus ZC minus ZL by ZC plus ZL into I dash. Therefore, minus 25.82 minus 120.18 divided by 25.82 plus 120.18 into 100 divided by 120.18. Get the reflected current is minus 537 amperes. We have another formula also, minus V double dash by ZL. You can use that formula. Minus, how much you get this? This value is minus the value of V dash is 64.63, 120.18. You get this one is also 537.74 amperes. 537.74 amperes. Okay, both the cases you get the same answers for voltage waveform also, the current waveform also. Okay, this is the first case. We are calculated a reflected current and transmitted voltage and currents for the traveling wave travel along the line to the cable. Now in second case, we will discuss. Now the surge is induced in cable. Now surge is induced in cable. It is traveling through the overhead transmission line. Already we calculated ZL and ZC. Okay. Now just to reverse the formulas, previous case, V equals to 2 into ZC divided by ZC plus ZL. For this case, current case or present case, don't confuse. The present case. For this case, it is shuffled. Okay. ZC is ZL, ZL is ZC. Keep in mind, because it is induced in cable flowing towards the transmission line. That's why 2 into ZL divided by ZL plus ZC into V dash. Okay, therefore 2 into 120.18 divided by 25.82 plus 120.18 into 100 to get the transmitted voltage is 164.32 kV. Next, V double dash. For previous case, it is Zc minus Zl divided by Zc plus Zl into V dash. For this case, V double dash is Zl minus Zc divided by Zl plus Zc into V dash. Zl is 120.18 minus 25.82 divided by 120.18 plus 25.82 into 100. To get V dash is 64.63 kV. Okay. Now, current wave. The current wave I equals to in a previous case it is 2 into Zl divided by Zl plus Zc. In this case it is 2 into Zc divided by Zc plus Zl into I dash. 2 into 25.2 into 25.18 divided by 25.18 plus 25.82. 25.82 divided by 25.82 into 120.18 into V dash divided by Zl. Zl is 120.18 and V dash is 100. Okay, therefore you get current equals to 1.369 kiloamperes. Now I double dash is minus, already we calculated minus, therefore minus V double dash by 2 can get I reflected current is, if you substitute those values, 4.63 divided by Zc 25.82, you can get the current is minus 2.5 kilo amperes. Okay, this is the way we will calculate the line terminated through a cable or cable terminated through a line. Okay, both the cases we can. Thank you for watching.